Well, that sounds promising. So, pause here is where we left off. We were talking about vectors and scalars. We said that in physics, everything is either a vector or a scalar. We said that scalars have magnitude only. Vectors have both magnitude and, fill in the word, direction. Vectors have both magnitude and direction. You'll learn we will do a little bit of vector mathematics this year, but I'm going to cheat. I'm going to keep everything in a nice straight line, and so the vector mathematics is not as tough. If you look over my left shoulder on that big whiteboard back there, that is vector mathematics in Physics 12. That's how we add two-dimensional directions together. We use lots of trig. In fact, if you take Physics 12, you'll find you'll get far better at trig than you ever thought possible. My grade 12s right now are good enough at SOHCAHTOA, at sine and cosine and tangent and Pythagoras, that they can almost do it writing nothing down using only their calculator, showing no work. And I've encouraged them to get that good. Of course, on a test or a quiz, Colby, we show our work to avoid making a dumb mistake, but you'll see if you ever watch my Physics 12 lessons, I really encourage them, hey, can you do this without writing anything down? That's becoming an expert. That's not lazy. That's becoming really, really good. Just understand on a quiz or a test, show more work to avoid making a dumb mistake. So we talked last day, we said that speed was a scalar and that velocity was a vector. I don't have a dumb good way, though, to help you remember the other two. We had distance and displacement. One of them was a scalar, one of them was a vector. Which one was which? Which was a scalar, distance or displacement? Distance. Evan, distance. And we tried to explain it like this. I said distance asks how many steps you've taken, how far have you traveled. If each step that I take right now is 1 meter long, and I go 1, 2, 3 steps forward, 4, 5, 2 more steps back for a total of 5 steps, my distance is 5 meters, 5 steps. My displacement is my change in position. Where did I start? Back there. Where did I end up? 1 meter forward. We would say your displacement is positive 1 meter. That's the key difference. We're going to elaborate on that a lot more. And also, I think I told you last day, I have a big problem. I constantly verbally say displacement when I mean distance or distance when I mean displacement. I will almost never mix them up in writing, but I'll have to catch myself verbally. It's still something I'm working on 20 years into teaching. Example 2 says this. Suppose that you run 3 different paths from location A to location B. Along which path would your distance be different from your displacement? Or let's reverse the question. Along which path is your distance the same as your displacement? There's only one path that satisfies that. Which path is that? A, B, or C? Which one is your distance and your displacement identical in magnitude? Path number, A, B, and C. Path number 2. You got to get more organized. I hole punch everything. You know that, eh? So then the correct answer is going to be this path has a different distance and displacement. This path has a different distance and displacement. The displacement, Chantal, would be the straight line connecting them. The distance is the little slanty line or the little curvy line that the person walked. We're going to talk often about position. We want to try and be as concise but as accurate as possible. Least writing, maximum organization. So if you're someone who's lazy but organized, you'll like this. I am lazy but organized. It says use the number line below to give positions of these objects. Don't forget units. It's going to start out hopefully very obvious, but I'm starting out obvious so that when I get more complicated, we can use the same rules and say it still works the same way. We just got to do a bit more thinking. So on this number line, what's the position of the heart? Units. I said don't forget units. Meters. I looked at the what says meters there. Yes. Positive 4 meters. Now we're going to decide from now on if you write 4 meters, I know you mean positive, just like in math when you don't put a sign in front of a number, we understand it's positive. Or you could say 4 meters to the right. I would live with that as well. But writing 4 meters to the right is longer than 4. What's the position of the diamond? Colby. I would take negative 4 meters. I would also take 4 meters to the left. What I wouldn't accept is negative 4 to the left. Because negative left would really mean which direction? Right? Right. Don't use one or the other. I'm really going to encourage you. Let's just use negative and positive. The only time I start going like right, left, or north, south is if the question has multiple directions and it's very complicated. We typically start doing that in physics 12. What's the position of the cross? And I would be fussy if you just wrote 0. I'd take a half mark off. It's 0. The units are still there. How far has it traveled? 0 meters. It is really going to be worth memorizing what units go with which concepts. In fact, I hate memorizing stuff. Those of you that have had me before have heard me go on rants about how much I dislike memorizing stuff. And what that means, Justin, is if I tell you that something is worth memorizing, it's really worth memorizing. The people on YouTube are freaking out because they're listening with headphones right now, and I just screamed right into the speaker. I apologize to those of you on YouTube right now. So we can use arrows to represent, distance then, displacement then is measured in meters. We can use arrows to represent a displacement that actually can show the direction of something. What word is right here, begins with the letter F, Ibrahim? Next to the little bicycle? Final. I'd like a good abbreviation for the word final. What would be a good letter to use as an abbreviation for the word final? We're going to use an F for the rest of the year. Ibrahim, the other one is called initial. That's the fancy word for starting. We're going to use the word initial. What would be a good letter to use for an abbreviation for the word initial? I'm going to use that from now on. I'm going to use a little subscript so that it's going to be beneath whatever we're talking about. If you see an F, that means that's the final. If you see an I, that's the initial. It's good organization, but very little writing. So a bike moving along a number line from 4 meters to negative 3 meters, we would draw it with little arrows like that, except I would, instead of writing the word final, I would probably call this displacement final, and I would call this one here displacement initial, with a little vector symbol above it. Oh yeah, there. I said we'll often use a variable x or d to symbolize a position, and subscripts I or f to show initial and final. Turn the page. So we're giving you lots of handy shorthand notation. So draw an arrow showing an object that moves from the negative 4 position to the positive 5 meter position. First thing I'll do is I'll put a dot at the negative 4 position, and I'll label that distance or displacement initial right there. Oh, everybody look up at the screen for a second. I will always make my eyes with a little tiny curl on the end so you can tell it's not a 1. Otherwise, you might think it's a 1, and I can prevent that. Because the dot isn't always big enough for you to see in the back corner, but I'll try and make the little curly thing like an italicized I so that you can clearly see that's Mr. Duick's lowercase I. He's not talking about what, because we will use 1s and 2s as subscripts along the way as well. It moves to the 5 meter position. There is D final. Let's try that a little better, Mr. Duick. And if I wanted to show that path, I would draw a straight line as freehand as I can, probably better than I just drew. Could use a ruler if you wanted to, but I draw an arrow showing it moved from negative 4 to positive 5. The next two questions ask almost the same thing. For the first part, we'll write D equals. For the second part, we'll write D vector sign equals, displacement and distance. How far, what's this object's distance? How far did it travel? How many steps did it take going from negative 4 to positive 5? 9. Or is that a German student saying no? 9? Nothing? Okay. I don't get it. Okay. 9. Nothing? Really? Ethan, what's the object's displacement? Don't overcomplicate it. I got to be fussy. I would take that, but if I was giving the instructions to Chantel, I would probably verbally say positive 9 meters, but I would just write 9 meters just to emphasize the positive. I'm fine if you don't from now on as well. But in this case, the displacement and the distance have the same magnitude, but here there's that positive, which I didn't bother writing, really suggests which direction. I'm looking for a word that begins with the letter R and rhymes with light. To the right. Okay. Draw an arrow showing an object that moves from the 7 position. Okay, there's the 7 position, and that's going to be D initial, to the 1 meter position. Okay, there's D final. Vector symbol, vector symbol. Draw an arrow. Okay. Lorenzo, what's this object's distance? How far did it travel? Nope. Yes, distance is a scalar. Doesn't care about direction. So we're going to write D equals 6 meters. Lorenzo, what's this object's displacement? And you could say negative 6 meters, or you could say 6 meters to the left, or you could say 6 meters west if there was a compass rose on here, but negative 6 is cleaner. Now we're going to get a bit technical. We're going to talk about speed versus velocity. We're going to talk about average speed. Average speed is the change in distance over the change in time. Wait a minute, Mr. Dewick, that's not what you wrote. You wrote triangle D over triangle T. I did, although that triangle is a Greek letter. Does anybody know what Greek letter the triangle is? Faith. It's a delta. It is actually where our capital D eventually came from. It's just the triangle got tilted over the years and then got curved over the years. It's a delta. So I would read that out loud as delta D over delta T. But in English, when you see a delta, that means change in. As an equation, we write this. The symbol for speed is a V. Mr. Dewick, that's velocity. No, everybody look up, watch the screen, watch the screen, watch the screen. That's velocity with the vector sign. That's speed. Velocity, speed. One's a scalar, no vector sign. One's a vector sign. It's a very powerful shorthand notation, Aisha. It's really minimal writing and maximum organization, but you got to pay attention. Sorry. And that's going to be your final distance minus your initial distance divided by the time. We get a bit sloppy with time. Time is always a change in, Evan, and so because time is always a change in, we get lazy, and over time, no pun intended, we stop putting a triangle in front of it because there's no way to measure time without starting a stopwatch and stopping a stopwatch. That's how you measure time. It's always an initial and a final, and then if you start from 0, you don't need to subtract, but you subtract. Units. Did I go on my rant about how it's worth memorizing what units go with what? It's worth memorizing what units go with what. Justin, my friend, do you remember what units I said distance was measured in? Begins with letter M. Go look at the number line on the previous page and check. Yep. No, what units it's measured in? Begins with letter M. Look at the number line and the units, my friend. Units. Yes! Loud and proud. And this, by the way, commit this to memory. You will, because I'll be flogging everybody with this. But Justin, what are the units for distance? Per, because meters is on top. What are the units for time, Justin, my friends? My friend. Starts with letter S. Yep. The standard SI units for time is seconds, for distance is meters, which means the units for speed is meters per second. You can sort of see the units hidden in there. Meters over seconds. And speed is a scalar. What this means, Justin, my friend, is anytime you see a number with a meters per second next to that number, you know it's a speed or a velocity. Which one? Oh, if there's a direction also attached, it's a velocity. If there's no direction, much like some of your careers, it's a nothing. It's a scalar. Brady just got that? Turn the page. Brady, my friend, average velocity is change in displacement over change in time. You'll notice it looks almost identical to what we wrote on the previous page, but on the previous page, I didn't have a vector sign above the letter D, because that was distance, Mackenzie. Here I got a vector sign above the letter D, displacement. In other words, for that little walking analogy that I did with you a few minutes ago, for displacement, you'd put the number 1 in. For distance, you put the number 5 in. Okay? Oh, where delta triangle means what? Change in. As an equation, we say this. Velocity with the vector symbol is equal to final displacement position minus initial displacement position all over time. And once again, we get sloppy and lazy with time. It's always a change in, and so we kind of get sick and tired of putting the delta, and so we stop over time. Justin, my friend, what are the units for distance and displacement? Same units. Yep. What are the units for time? And also you'll notice time is a scalar. No vector sign ever goes above. It's always going to be a scalar. Time is one of the big scalars. It has no direction. Well, I watched a Star Trek movie where they went backwards in time. No, time has no direction. We're going to stay in our real physics world. We're not going to go to our Star Trek universe. So velocity, scalar or vector? Vector, circle vector. We're going to go right to the tone. You have no homework today except to get caught up. We're going to finish lesson off Thursday, and I think Friday we're going to do a fun lab, so that'll give you no homework for your long weekend. So let's keep going here. Way back in example 1 on the front page, on the first page, we did a bug strip. Suppose it took 30 seconds. What's the bug's average speed, which is going to be distance over time? What's the bug's average velocity, which is going to be the displacement over time? They're going to be two different answers. Both of them are going to be over 30, because the time in both situations is 30. But from that first page, where we had that number line with the bug walking on it there, what was the distance on that number line at the very, very beginning on the first page? It's going to be on the front page, right here, example 1. A bug walks along a number line. What distance did the bug walk? 14. Now, y'all ready for the big secret? You just wrote a test on sig figs and scientific, and sig figs and sig figs and sig figs. Yes? Morgan, for the rest of the year, I don't care about sig figs. I will talk about them, and I'll tell you technically what the answer should go to the correct number of sig figs, but I'm not going to take any marks off for sig figs anymore. That's the one time I'm going to do it. Chantel just gave a great big sigh of relief. I like that. So on your calculator, what is 14 divided by 30, please? As a decimal, please. We don't go with fractions in physics. 0.46 repeating. So I'm going to say, how about 0.467, not 466. 46 repeating would be good, but if you said 0.46, I'm taking a half mark off. 0.47 if you go to 2 sig figs. 0.467 if you go to 3 sig figs. Justin, what are the units?
Meters.
Per?
Second.
Nice recovery. Smooth. I had it in brackets there. You spotted that, right, kiddo? I'm coming back to you on units today, so just be ready. What's the bug's average velocity? What was the displacement the bug went? It was not 14. It was far less.
-6.
This one I can do in my head, but double check me on a calculator. -0.2, yes? Yes? No? Yes? I think. Brady, what that is telling us is, on average, the bug was traveling backwards. May have been going forwards for a while, but on average, it went backwards. Okay? That's the difference between velocity, displacement, and distance. Most of you, well, let me come back to that. We're going to finish with this, I think. Yep, I got 3 minutes. If average velocity, I'm going to write that as VAV. I'm going to use subscripts an awful lot this year. It's a good way to stay organized without writing a lot. Equals displacement over time. What would be an equation for displacement and time? Write a little line down the middle here. I'm going to challenge you. I'm going to push you. I'm going to encourage you. Put the phone away, Alan, and leave it away. Okay? Pretty obvious when you guys are staring at the phone. Don't do that. I'm going to challenge you, Louisa, to learn a skill called formula manipulation. If you wrap your, it's weird algebra. If you can wrap your brain around it, Maddie, you will have dropped your memorization by about 90%. I'm going to push this hard and heavy. I'm going to get you to get far better at doing math in your head than you ever thought possible. And again, Aisha, if you get the hang of it, I'm telling you, you've dropped your memorization by about 90%. Here's what I mean. How many different variables are there in that equation right there, Aisha? That's actually 3 equations in one. If you want to, you can memorize all 3. I'm going to teach you how you can derive them in your head from one equation. You ready? I want to get an equation for displacement. I want to get the d by itself. See the d, see the d, see the d, see the d, see the d? There's also a t. What's the t doing to the d mathematically? Adding, subtracting, multiplying, or dividing? How will I move the t over to the other side then? So you're telling me the v average would drop down like a domino because it was just sitting on that left side already? You're telling me I would multiply the t over and then look up, look up, look up, look up, look up, look up, keep looking up. Don't write this down. That equals d, but do you mind, instead of putting the equals d on that side, can I put the d equals on this side? Because that's where we're used to seeing it. There's the equation for displacement, if you know the average velocity and the time. Don't memorize it. I'll teach you how to derive it. This one is on your green formula sheet, but you're going to find as the year progresses, I give you fewer and fewer and fewer variations on the equations. We're going to learn how to rewrite them in our head. It's a nice place to be. Hannah, what's the second thing it wants me to get by itself? It says, write an equation for displacement and for? Getting the t by itself here is yucky because it's in the bottom. But wait a minute. I've got the t by itself on the top right here, but right next to it there's a v. What's the v doing to the t? Adding, subtracting, multiplying, or dividing? How do I move it over? Yep. An equation for time is displacement, and I forgot to put the vector signs over here, divided by average velocity. You do that one whenever you're planning a trip. How long will it take us to get there? How far are we going? We're going about this fast on average. Divide. That's how long it takes to get there. We're going to pause here. We're going to pick up with this weird stuff next class. Make sure you have a calculator next class.